Okay, Abby, so for number 3, what shape are we talking about? Okay, so that's important. Let's draw our picture first, okay? I'm drawing in white, which does not do anything. Okay, so we draw a rectangle. That's maybe too fat. And we're going to call it FGHJ. F, G, H, and then J. So anytime that you're labeling these shapes, just go in clockwise order around the shape with the letters that they give you for the name of the shape, okay? So now we're supposed to decide whether the statement is always or sometimes true and then explain. So the statement is that angle G is congruent to angle H. So that would be angle G is congruent to angle H, okay? Now, do you have your quadrilateral family tree paper with you? Okay, so look at the rectangle on there. What do we know about the angles of a rectangle? Okay, so that's the diagonals. What do we know about the angles? Yes, Natalie. So we have 4 right angles. So if all 4 of those angles are right angles, and they're always right angles, are they always congruent? So this one would be always. And it's because a rectangle has 4 right angles. Okay, does that make sense? Okay, so then for number 4, you're going to do the same thing. You can draw your rectangle, okay? And remember, it's F, G, H, J. And it tells you that JF is congruent to FG. So here's JF and here's FG. So does that look like the information that we have for a rectangle? So since it could be a square, is that always going to be true for a rectangle or only sometimes? Okay, so that's only sometimes. And then that's because the sides are consecutive sides are only congruent if it's also a square. Okay, Does that make sense, Abby? Abby, are you good with that? Okay. Hold on and let me look at number 18 with Charlotte Ann, okay? Okay, Charlotte Ann. So for number 18, it wants to know what the measure of PTQ is. And you asked if it was 90 degrees. So we're talking about this angle here. Now, we know that this is a rectangle, right? So if you look at your quadrilateral family tree handout, what do you know about the diagonals of a rectangle? Okay, so we know that they're congruent. Now look over next to that for the rhombus and see what those diagonals do. So in a rhombus, they're perpendicular, which would mean that that would be a 90-degree angle. But in a rectangle, they're not perpendicular. Okay, so that's not going to be 90 degrees there. But we can still figure out what that angle is. So what we need to do, we know that it's a rectangle, so we know that this is a right angle, correct? So can we figure out what that small angle is up there? Okay, what is it? Okay, so since that's 28, now we know that the diagonals are congruent. So we know this is congruent to that, right? So if you have a triangle where your two sides are congruent, what do we know about these two angles down here? Okay, so since those are congruent, we know that this one is also 28 degrees, right? And then what do the interior angles of a triangle add up to? So now can you figure out what that angle is? Okay, good. All right, Natalie, you need help on number 5? Okay, so for number 5, we're supposed to classify the parallelogram and then explain. So look at let's see, look at your quadrilateral family tree. Remember, this is going to be either a rectangle, a rhombus, or a square, okay? So look at those three things down there and see which one talks about diagonals being perpendicular. Okay, now, does it also say that diagonals bisect each other? Oh, but it does, because remember, a rhombus has the same traits as a parallelogram too. Like, remember, it has all of its own things and everything from above it, right? But do we know anything about the sides of that shape? Are you okay over there, Abby? Okay, so we don't know anything about the sides of the shape, so we can't really tell if it's a square. So the most specific we can get is that it's a rhombus. And the reason would be because your diagonals are perpendicular. If they were congruent, then it would be we could say it was a square. But since they're not congruent, that also proves it's a rhombus. Does that make sense? Okay. So why do you think 6 is a square? So it has congruent sides, yes, and it also has all 90-degree angles. See, if we know that this angle is a right angle, we know this one is a right angle as well because opposite angles are congruent. And then we know that the interior angles add up to 360. And if opposite angles are congruent, these two are going to be 90 also. Does that make sense? So it's got the 4 right angles, and then it's got these 2 adjacent congruent sides. So if you look at your family tree, the shapes that have 2 adjacent congruent sides are either a rhombus or a square. A rhombus does not have the 90-degree angles, but a square does. So that one is a square. Abby, did you say you thought 10 was a square? Well, tell me why you think it's a square. Okay, we got to go with more than just that, though. So look at your family tree, look at the properties of a square. What do we know about that shape? The diagonals are congruent. And what kind of angle do they meet at? So they are perpendicular, right? Okay, so you see, if you look at your family tree, you've got that diagonals are congruent listed under a rectangle. And then the fact that they're perpendicular is listed under a rhombus. So the only shape that has traits of both a rectangle and a rhombus is a square. So number 10 is a square. Does that make sense? Okay, good. All right, Isabel, just a second. I'll pull up number 2. Charlotte Ann, you thought number 10 was a rhombus? Okay, so when you look at the diagram, you see how the diagonals are broken out into 4 congruent parts. So since that will tell you that like each diagonal is 2 of the same length segments, okay? So for that, that's going to mean that your diagonals are both the same length. In a rhombus, they're not the same length, but in a rectangle, they are. Does that make sense? Okay. All right, Isabel, so for number 2, we are working on a rhombus, okay? So remember, a rhombus looks kind of like this, right? And we're supposed to label it A, B, C, D. A, B, C, D. Okay. Now, the statement tells us that DA is congruent to AB. So you've got DA here and AB here. Now, look at your family tree, or that flowchart thing we used in class yesterday, and look at the picture of a rhombus down there. What do we know about the sides of a rhombus? Okay, so since all 4 sides are congruent, will those 2 sides always be congruent to each other on a rhombus? Okay, so it will be, for number 2, your answer will be always, and it's because a rhombus has 4 congruent sides. Does that make sense? Okay, now let me pull up the bookwork, okay? Okay, so in the bookwork for number 10, We're dealing with a rectangle here, okay? So we're going to draw a picture of a rectangle. And we're going to call it WXYZ. WXYZ. All right. Now, number 10 tells us that WX is congruent to YZ. So WX would be congruent to YZ. Now, if we look at our properties of a rectangle, do we know that the two opposite sides are always congruent on a rectangle? Remember when you're looking on that family tree that all of the, yeah, it is also a parallelogram. So all of the traits from the shape above it apply to that shape too. So on a rectangle, opposite sides are congruent always. So the answer for that one would be always, because opposite sides are congruent. All right, Megan, so for number 11, what shape did you get that it is? Okay, so the properties of a rhombus that we know would apply to this are that it has four congruent sides. We don't know anything about the diagonals on this one. So that would be your explanation, that it has four congruent sides. Okay. And then for number 29 from the bookwork. So 29 is a little bit tricky. On the worksheet, all of the ones are either rectangle, rhombus, or square. So what are you explaining number 29 as on the bookwork? Okay, hold on and let me pull up a picture of it, okay? Okay, so on your bookwork, we haven't done kites yet, okay? We're just talking about parallelograms, rectangles, rhombus, and squares. Oh my. So if we look at this one, we've got opposite sides are congruent, right? We don't know anything about the diagonals. All we know is that it's a quadrilateral for sure. So the fact that we have two opposite sets of congruent sides, that will tell us that it is a parallelogram because we know that opposite sides are congruent. And we can't get any more specific than that. Does that make sense? Okay, good. Okay, Natalie, 16 on practice A. We're supposed to find the length of XY. So do you remember in class what I said you have to do to find the length of that side? All right, Alicia. So what do we know about those diagonals, about the angle formed by those diagonals? Okay. So if this is a right angle here, okay, and what we're solving for is this length. Now, do we know any of the other angles inside that triangle maybe? Okay, so not the whole angle X is 34, but that small part of it is 34. Okay. So do we also know the length of this? So what is it? Okay. So if we have a right triangle where this is 7, this angle here is 34 degrees, do we know something that helps us find the hypotenuse? Yeah, our trig functions. So which one uses, from this 34-degree angle, the opposite and the hypotenuse? Yeah, so you're going to say the sine of 34 equals opposite over hypotenuse. You're welcome. Okay, Natalie, so on a proof, what are we going to put for number 1? Okay, RECT is a rectangle because that's our given. So then for number 2, the statement is that RT is congruent to EC. So RT is congruent to EC, and that RT is parallel to EC. So how do we know those things? So it's not quite a theorem. This one is because of the definition of a rectangle. Does that make sense? So now if you look at number 3, the reason is that alternate interior angles are congruent. Now, take a second and look at what we're trying to prove, okay? We're trying to prove that triangle ART, so this triangle, is congruent to triangle ACE, this triangle. So this statement is going to have something to do with alternate interior angles. And since we're working on those 2 triangles, what are our 2 alternate interior angles that would be pertinent to that? So those are not alternate interior angles. Alternate interior are on either side of a transversal. Those 2 that you said are vertical angles. Okay, so if you have 2 parallel lines cut by a transversal, right? Your alternate interior angles are going to be this angle and this angle, or this angle and this angle. So what angles in that picture up there look like any of those alternate interior angles from the diagram at the bottom? So if I have 2 parallel lines cut by transversal, which of those angles are going to be in those triangles that we're trying to prove? So RAT, Natalie, is this angle, and EAC is this angle. Do those look like something from this picture? So which two? Yes, those work. I think the answer key has them listed as ART and ACE. It just starts here and goes ART and ACE. Does that part make sense now? Okay, so then the next thing, our reason is that vertical angles are congruent. So what vertical angles do we have in those two triangles now? Yes, now those two come back into play. And now, so we know that for RT is congruent to EC, we've proved that. Let me change colors. Okay, so we've said RT is congruent to EC, right? We've said that RT is parallel to EC. For number 3, we said that angle ART and ACE are congruent, right? And then for step 4, we said RAT and EAC are congruent. So when we're trying to prove that those two triangles are congruent, what do we know? Yes, angle, angle, side, because it's two angles and the side not included in them. Good job. Okay, Devin, so for number 16, what do we know about the angle formed by those diagonals? Okay, they do bisect each other, but look at, are you looking at your family tree? Okay, so look and see what it says about the diagonals for a rhombus. So if they're perpendicular, what does that mean that angle is? Okay, good. That means that this is a 90-degree angle. Okay, so we're trying to find the length of XY. Do we know anything else about the angles up here? Like, do you know what this angle here is? Okay, so we know that that's 34 degrees then, right? Do we know, since the diagonals bisect each other, we also know that this length here is 7, right? Okay, so what we're looking at now is a right triangle, correct? We know that this bottom here is 7. We know that that angle is 34 degrees. And what we're trying to find is this side over here, right? The hypotenuse. So do we know a way to use that side that's opposite from the 34-degree angle to solve for the hypotenuse? Like, we know an angle measure, right? We know a side that's opposite from that angle. And we're solving for the hypotenuse. Does it sound like anything we've done before? So it's just from the last chapter. Ring a bell? Yeah, SOHCAHTOA. But it's SOH. So which one uses opposite and hypotenuse? All right, so do you remember how to use that then? Remember, you got to take the sine of a degree, so sine of that angle, 34 degrees, equals opposite over hypotenuse, which is our opposite side from the 34 degrees. Okay, so 7 over our hypotenuse, which is x. Now, do you remember what to do? Okay, good. Well, remember, if the x is on the bottom, we've got to get it by itself, right? So we're going to multiply by x on both sides. And then we still have to get x by itself. So what we have here is x times the sine of 34 equals 7. We still need x by itself, so we're going to have to divide by the sine of 34. So those are going to cancel there. And we're going to have x equals 7 divided by the sine of 34. No, that's not right. So did you do 7 divided by parentheses? Sorry, that's my alarm. 7 divided by parentheses, sine 34, close parentheses? No, it needs to be 7 divided by the sine of 34. Okay, you're welcome. All right, I'm going to have to get off here because I got to go get my kids from the bus. If you have any other questions, Devin, just shoot me an email, okay? Okay, you're welcome. See you tomorrow.